So this topic is titled Rotational Kinetic Energy, but I'm introducing two formulas, one of which is for rotational kinetic energy, but the other one is for how work is done rotationally. You could maybe say rotational work, I suppose. But I think the way to look at these two formulas, the work formula is torque times angular displacement. And the rotational kinetic energy formula is 1/2 I omega squared, where I is moment of inertia and omega is angular velocity. A way to think about this, though, that maybe makes it all make a little more sense is if you look at work, you could say, well, there's a linear version of the formula for work, which is force times displacement. We know that we had some other ones, right? Like there could be an FD cosine theta. We used D before, but I wrote it this way to make the transition to a rotational formula make more sense. So the rotational version of that would be torque, again, times angular displacement. And so really I've replaced force with torque and displacement with angular displacement. And similarly for kinetic energy, I take 1/2 mv squared. M is for mass. So I'm going to replace that with the rotational analog for mass, which is the moment of inertia. V is velocity, so omega is angular velocity. I'm not really proving these formulas, but they do make a lot of sense in the way that we have formulated rotational physics to have a connection with non-rotational or linear motion in the physics that describes that.